Okay, 8.3 is to control quality, to make sure we're doing the right thing. And basically, we're going to have the project management plan coming in with quality metrics and checklists, and then some of the performance data, approved changes, that sort of thing. Our tools and techniques, we'll use the 7 old and new tools that we've talked about. But most importantly, we're going to talk about inspection and how we can use that. Let's shut Palestrina off and concentrate on the tools and techniques. The idea behind controlling quality is to identify poor quality in the process or in the project or in the product. So we've got 3 P's. We've got to check for quality and correct it. We have to validate the deliverables for the stakeholders, for example, for the customer, and make sure we're maintaining our earned value. One of the ways of looking at quality is to take a look at the reasons that quality might fail. And then we can see lack of management leadership or commitment is one reason. If management is not supporting quality, we're in big trouble. And in fact, quality should be controlled at least at the vice presidential level, very close to the top, because quality is the first thing that gets whacked when we run into trouble. I remember a colleague of mine was a quality software engineer at IBM, and the president of the company at that time, Lou Gerstner, knew nothing about software. He came from Pepsi-Cola or Coke or someplace like that. IBM was running into a bit of a bad patch, and so his first reaction was cancel quality. So the Toronto labs had to let go their entire quality department to make budget. That was the first thing on the chopping block was quality. Well, of course, that in the short term may work, but in the long term, it's absolute disaster. The second thing is that we, being who we are, expect quick results. We expect quality to turn around overnight. And in fact, the Japanese are leaders in this field. They know this is a decade-long activity. It takes a long time to get quality improved. If employees are not empowered to actually make quality changes, not going to happen. If we have a failure to see the need for a cultural change, and the change towards quality is a change in the cultural organization, and as we all know, change is never easy. A limited scope of application. We're not implementing quality throughout the entire product line. Emphasis on the internal, not the external customer, not good. If our customers are not happy, we're in big trouble. Sometimes we refer to this as big quality and little quality. Big quality basically is proactive top management support, and corresponding little quality is no top management support. Big quality is a change in culture. Little quality is just lip service, no serious attempt to endure it. Big quality is well-articulated strategies. Little quality, no strategy at all. Big quality concepts are built into the organization's fabric. Then the philosophy here, little quality, is not integrated into the end-to-end processors. So here you get persistent long-term results. Here you get fast faders. Graphically, it looks like this. Little quality, we get a little improvement right out the bat and then die a painful death. Big quality goes on and on and on, improving quality over a long period of time. So some success stories. Selectron cut its defects from 100 parts per million to 2 parts per million, and at the same time reduced cost per cycle time. Kodak cut defects in a blood machine tips from 27,000 parts per million to 2/3 of a part per million in 4 years. And that, my friends, is a way under Six Sigma. That's really impressive. Process factors that affect quality negatively, inexperienced staff, irrational schedules. Oh, that's a big one. Anytime you get an irrational schedule, quality is the first thing to go out the window. Inexperienced managers, unstable requirements, unstructured methods, not using instructions, perfunctory testing, no metrics, low design reuse, low reuse. And the list goes on. low-level software languages, crowded offices. You'd be surprised how quality improves when your working space improves too. Poor organizations, generalists only, not specialists, severe size constraint or severe performance goals, that's going to drive our quality down. Ordinary tools, unstable hardware, marginal computers, manual planning, there's a bunch of things. Well, why should we resist quality? Quality, like motherhood, is a wonderful thing. Well, pointy-haired bosses, first of all, view quality as the cost center and something they have to pay for. They're not looking at the long-term cost that a little bit paid for quality up front saves an enormous amount of money and embarrassment and litigation downstream. Professionals assume they're always grading a professional product. We are professional, we're engineers. How could we make a mistake? We're PNGs. To institute a quality assurance function is insulting, implies we're going to make mistakes. Where should it be cited in the org chart? Well, we mentioned right up to the vice president level. And it's also viewed as being non-productive, red tape organization. Okay, the inputs to control quality, the standard bunch that we've talked about. The control quality, well, we can use our 7 tools wherever possible. Visualization is always used in quality reports. You want to show and tell your improvement with graphs. Nothing speaks stronger than a good graph when it comes to improving quality. Now we want to get back to the most important tool of all in the control. How do we check for quality? Well, we do through 3 techniques called reviews, inspections, and walkthroughs. Reviews are formal reviews of a process and its deliverable. Walkthroughs are completely informal, normally done by the project team, and inspections are somewhat in between, a combination of both. If we rank the 3 of them according to cost, efficiency, time to do, difficulties to do, and then the effectiveness per dollar spent, it turns out reviews are the most expensive, the most efficient, take the longest, they're really hard to do, and they don't have a very good efficiency compared to cost. Walkthroughs are the reverse. They're cheap, not very efficient, don't take a lot of time, they're not hard to do, and they have a low ratio. Inspections are in the middle, like Mama Bear. They're not expensive, they're not cheap, but they give you the best bang for the buck in terms of the efficiency per dollar spent. Reviews are going to be driven by management, and there's certain pieces of work that we do where we simply have to do a review. In fact, we may be mandated by law. If you're building a nuclear reactor, you have to have a technical review of that nuclear reactor. Reviews are like a PhD defense or a book review. The unit under test produces a document. It's inputted to the review board. The review board produces an output document, either correcting or ordering that the work be redone. The review answers questions like, it's supposed to do what, does it do what it's supposed to do? Is it complete? Is it correct? Is it reusable? Has it got metrics associated with it? Now, the review process are very, very simple. The originating team, which we'll call the OT, creates a deliverable. The deliverable is sent to the review board members. The members read and prepare comments. They meet and review. They can ask for clarification for the originating team, but that's it. Then they write a report. Now, the report basically is going to produce a summary report saying what's reviewed, who did it, what were the conclusions, what follow-up work is necessary, and then make sure the data is included in the project database for retrieval later on. Now let's take a look at inspections, because they are by far the most common type of checking work that's actually been done. Inspections basically come from a technical piece of work that cannot be basically checked by any other mechanisms. So suppose you have a brain surgeon. Brain surgeon goes and operates on patient X. He opens up the skull, finds a funny looking green thing in there and rips it out. Patient dies. Now it's very sad that the patient has died. Is the process over? No. What happens next is that the brain surgeon then has to do an inspection in front of like-minded colleagues and explain to the like-minded colleagues what he has done. And they would ask him questions like, well, when you opened up the brain, did you see anything unusual? Yeah, I saw this little green thing. And what did you do with the little green thing? Oh, I ripped it out. And what happened to the patient? The patient died. Maybe we shouldn't be ripping little green things out of people's brains. Now, the point of the inspection is not to embarrass or to blame the person who did the work. It's to make sure that you explain to a group of your comrades who are technically competent to understand what you've done, to make sure that we make the process better next time around. One of my favorite ads from about 10 years ago was a potato chip commercial. This bald-headed guy said to the team, "Make me the perfect potato chip." And he sends the team of 3 away, and they beaver away in the labs and come up with a potato chip. They bring it back to the bald guy and said, "Here you go, sir, the world's perfect potato chip." He picks up the potato chip and crunches it, and he said, "Oh, that's magnificent." And the half-eaten chip he hands back to the team and says, "Now, make it more perfect." I like that. Make it more perfect, because that's what you do with an inspection or even a review. The whole point is to make the process more perfect. It can never be perfect. We want to improve it. Now, an inspection basically breaks down into about 5 different categories, and we'll go through these. First of all, the process will define the initialization. We've created a deliverable. It has to be inspected. So the process says, inspect the piece of work done. Let's use requirements as an example. The team has created the requirement specification document. That's the deliverable. It now hits the gate for requirements. It has to be approved by an inspection team. A leader is chosen for the actual team itself. The leader then sets up the inspection process, and he builds the inspection plan for the stage. This can be shrunk to a template, of course. The piece of work is going to be inspected. Now, the source is going to be its input, so this will be the requirements group. The work package is going to define a set of rules to create the piece of work, and there'll be a checklist for the inspection to check to make sure we get it done correctly. And the work package will define a procedure that we have to make sure that's followed. So the inspection has 4 components: the entry, the kickoff, the checking, and the logging. The entry, when the doer, the originating team, is ready to have a piece of work presented, he gives the document to the leader. The leader then qualifies the document to weed out losers. Losers in the sense of Dilbert, okay, the big L loser, because there's no point in inspecting a piece of crap. If you've done something just to get the deadline met, then you haven't got quality in your product. Inspections cost money. The leader has to be sure this document is worthy of being inspected. If it is, then he calls the kickoff meeting. The kickoff meeting gets the inspection team together. Then he makes sure that the checkers are given individual tasks. In fact, likely they're given individual roles to play. They'll hand out the materials and hand out the schedules, set improvement targets. Then the team members, and this is important, go away by themselves, just like a Delphi method, read the materials and make checks. The checkers do their checking to make sure they've got it done by the time of the logging meeting. They have to follow the rules of inspection. Inspection itself is a process which also has to be inspected. Self-referential inspection. If we don't have an inspection process, we can't improve the inspection process. Now we're going to record the actual types of defects to record. Now, not all defects are created equal. Some people suggest using major defect, minor defect. The more common one is to use the 4-level defect, which is basically a rewrite of the Likert scale, and we'll come back to that in a few minutes. The checkers can play role playing. One checker can pretend he's the client, another can pretend he's the tester, a third can pretend he's the system man, a fourth financial guru, and so on. Now at the logging meeting, the purposes of the meeting is for everyone to get together and record all the identified defects that you've observed. You're also trying to encourage synergy in the defect detection. This happens all the time in thesis defenses. One of the examiners finds a problem in the thesis, the other two jump in and start ripping it open like a shark that smelled blood in the water with his buddies, and it becomes a feeding frenzy. Well, I don't mean to say feeding frenzy, but to encourage synergy. The whole point is to get defects out of the product, not to embarrass people, even though, of course, it's embarrassing to have defects explained that you've missed. You want to record improvement suggestions, clarify questions of intent. At the meeting, the leader leads the actual activities. Somebody's appointed to be a scribe to actually keep track of what's been discussed. There's no discussion of the defects in terms of how they were caused. The meeting itself should be no longer than 2 hours, simply because this is intellectually challenging. What happens if the meeting is too long, your brain will get fried and you won't do a good job of detecting defects. The output from this is going to be an issues log saying, here are the things that we found. If you can put the defects into categorization buckets, that's also good. Now, in terms of defect categorization, the 4 level that I mentioned before is the useful way of looking at it. And again, this is a Likert scale. 0, 1, 2, 3, where 4 is no defect at all. That's a 0 to 5 ranking. A SEV 0, and we call the SEV 0, is catastrophic. The rocket has blown up, the spaceship has been destroyed, people are dead. A SEV 1 is very serious. Apollo 11 was the SEV 1. You're in danger of turning into catastrophic. A SEV 2 is really serious, but you can do a fairly simple workaround and avoid the bad thing. And then SEV 3 is minor, it's cosmetic, trivial, color should have been blue instead of red, that sort of thing. You can also explicitly categorize the defects in terms of logic defects or coding defect. Take a look at Pressman or the IEEE for a couple of examples of that. IBM's defect database format is worth looking at just because of the complexity of it. This was published in the IBM System Journal in 1985. Entry, product name, release identifier. Look at all the detail that they record for each one of those defects. Now, they do that because they're very concerned about making sure defects are contained. Then at the completion of the actual logging meeting, we've got to do an editing and a follow-up and finally an exit. The editor cleans up the logs from the meeting, classifies the issues into defects, categorizes the defects however you're going to categorize them, suggests improvement in the rules such that generate a change request in the inspection process so that 80% of the defects should be collected upstream, something like that. The follow-up is then done by the leader. He has to check to make sure that all the listed issues have been followed up. If the inspection was a disaster, the inspection will have to be redone. But generally speaking, there'll just be some issues that have to be corrected, like correcting cosmetic errors in a thesis and that sort of thing. All improvement suggestions are sent to the appropriate process owners. Haven't talked about much about this, and we should have. Any process that we have, requirements elicitation, for example, has to have a process owner, a person that is concerned with making sure that process is babied through to completion and gets rid of all the defects in the actual process itself. Then he has to report the inspection metrics, particularly the number of defects found. The process is going to dictate a series of exit criteria. We have to make sure the leader makes sure that they've all been successfully executed. Tom Guild describes this as a fishing net. What size of the fish are we willing to let through the net? Because with defects, we really want to catch the big one. In terms of process improvement, basically categorize the defects as some sort of ranking. Use the Pareto rule to identify the 3 most important. Suggest a change that will avoid them. Then track that change and see if it actually works. And I'm not quite sure what I mean by this because this is Unit 8. This is part of our continual process improvement. The inspection leader should be trained in the inspection process. It's a process like anything else. You need training in it. You have to be a leader. You have to be methodical. You have to be focused and able to control cats because you're going to have people that are going to go off in all directions. You have to keep them in line. Most of all, the leader has to be completely unbiased. Where does the inspection team come from? It comes from elsewhere in the organization. So if I've got requirements that I need inspected, I'm going to get a requirements person from a building B or building C, etc. If I'm biased and do something to hurt people on the actual team itself, eventually some of those people will in fact be analyzing my own particular work itself. And then it'll be payback time because I was biased towards them. They will in turn be biased likely towards me. In terms of inspection times, again, these are denominated by function point, hours per function point, just to give you some sort of idea. Joint application development is about 0.15. The execution of the actual time is about 0.25, and the fix about 1. So if we take a look at requirements, and we're spending about 15% of an hour to do a single function point, the execution is a bit higher than that, and the fixing is quite a bit more complicated. Similarly, in a field test, you're spending half an hour per function point in preparation and execution, and the fix can take up to 10 hours per function point. In terms of subtasks, you can expect, and these don't add up to 100, to spend the bulk of your time in checking, logging, and editing and process improvement, and administration, kickoff, and planning. Finally, the third of our processes for detecting defects is the walkthrough. And in this case here, we take part of the team to act as the assessors. Then the person that actually did the work on the team leads the team through to try and develop that. And in fact, in pair programming, this can be done shrunk down to 2, where one person presents the work, the other person does the criticism. Again, the walkthrough team is roughly about the same. Leader does the same thing as we do in inspections. These things are fairly short. The problem is that the leader who created the work is leading the team through the work. And that gives into the problem of, is your baby ugly? In the fall, there are a lot of small fairs around here, country fairs, that have beautiful baby contests. And new parents with their beautiful little babies enter their little Joe or little Joette, and then the most beautiful baby gets a prize. Now, do you think any of the judges of the beautiful baby contest should be one or two of the parents of the baby in the contest? Now, people, there are a lot of ugly new babies out there, a lot, but not to their parents. To their parents, they're the most beautiful creation God ever made. In other words, the parent of a child cannot objectively answer the question, is the baby ugly or beautiful? Of course he's beautiful. It's my baby. Can't be anything else. That's the problem with a walkthrough. The leader either deliberately will ignore ugly stuff or he knows he's made a mistake, or if he made a mistake or missed some work, he would have, if he'd seen it, he would have corrected it before the actual delivery of the deliverable. So he's blind in the sense that he cannot see the mistake. Otherwise, he would have fixed it at that point. This is why walkthroughs are the least efficient of the 3. Again, we can have review checklists, as we talked about in the last section. The review meeting of the report is system engineering, project management. We've already given an example. Again, in terms of pages per hour, Tom Gill publishes the following information. Requirements, you can do about 25 pages per hour and about 12 pages per hour in terms of execution, and that roughly corresponds to the function point mapping too. Now the outputs from this are basically, we found the defects, we want to make sure we're publishing all the information. If we've got changes that we've done, we want to make sure they've been done correctly and been inspected and accepted or rejected. Deliverables, we want to make sure we've validated them, that the quality control basically ensures that the deliverables are accepted, because this is going to feed into earned value. Then we may have change requests, we may have project management plan updates, other project updates, and so on. Finally, we conclude by taking a look at the old cost of quality model. And of course, I'm going to show you a new one. In the old days, we had, here's the cost of failures representing this cost coming down here. And the actual cost of failures basically dropping to zero as we conform to the specification. And here is the cost of defect appraisal costing more and more money as we approach 100%, costing enormous money here. And the argument is somewhere around 90%, we stop the quality improvement. In other words, the cost of the defect appraisal matches the cost of the failures, don't go any further. The new cost of quality model says horse feathers. The actual total cost of the quality never crosses that line. The cost of failures goes to zero. The cost of defect appraisal and prevention, so we don't have any problems here, then rises up to 100% here at the actual cost. So keep that in mind when you think about quality. And as they say in the pulpit, here endeth the lesson.